Right. Good evening. Welcome to somewhere over our 10th Cyber Cafe Sci, 14th, 15th, something like that. Feels like a very long time. Everyone's lost all track of time at the moment, and going over international time zones doesn't help. So, good afternoon to Jasmine, and good evening to anyone in the UK. And no, Chris, a Star Wars film was called Rogue One. I don't think there was a Star Wars heroine called Rogue. So, nice try. Welcome to Cyber Cafe Sci. I know some of you are new, so I'll just run through the incredibly strict, organised rules that we follow. We encourage you to have a beverage on hand so that you can relax. Non-alcoholic or alcoholic is fine. Different formats each time. Tonight will be more conversational, talking to Jasmine about life on rogue planets, and a very important thing, if at any point you have a question, just drop it in the Q&A window, drop it in the chat window. If you're watching on YouTube, Twitch, Twitter or Facebook, just drop it in the chat there. I will be switching between them to have an idea of what's going on, and I will bring in your questions or anything you'd like clarified and talked about. And with that, let me just make a couple of changes. Go. So we should be side by side for most of you. Jasmine, welcome. I know you were up late
Hello.
last night. I'm
Yeah,
assuming stargazing.
I just browse Twitter. I wish I was stargazing.
I will say, for those who didn't know, this isn't to do with astronomy. Twitter last night did get quite exciting for people in my field, and I got very, very little sleep. Possibly the largest attack Twitter's ever had, which was
Yeah.
fun to watch. So lots of drama there. Right. With that, Jasmine, can you do just a quick introduction of yourself? Tell us a bit about
Sure.
yourself, and then I'll introduce
So,
myself and Cafe Sci.
yeah. So, I'm currently a rising junior at Purdue University. I'm studying planetary science with a double major in atmospheric science. Um, I also do undergraduate research in the field of planetary atmospheres. So, that's kind of where I want to take my interests and apply them to. Um, I've found an interest in planetary atmospheres and astrobiology, so I kind of want to combine those and like do something with that and kind of search for life on other planets. That's always been my interest. Um, Other than science, I am in band. I'm involved in many other clubs at my university. So I encourage um, I encourage incoming students to join science majors. And I'm also involved in Women in Science, where I mentor um, a young woman that's coming into a science major that's similar to mine and just kind of help her transition to college life and get used to everything. So
Okay,
yeah, I'm just I'm a really big space nerd.
I think I actually, or Cafe Sci started following you, must have been a month or so ago, with one of our first astronomy podcasts, and
Yeah.
finally managed to get in touch much more recently. So I'm glad that we
Hmm.
did,
Yeah.
and I'm looking forward to this. Right. So for those who don't know, Cafe Sci is an open science movement, usually in coffee shops, art galleries, wine bars, anywhere else where the idea is you can engage in conversation about science for the price of a coffee. Cyber Cafe Sci, as the name suggests, is our little online version of it, because we realized trying to run it in a coffee shop was going to be problematic at the moment. And we've found that going online means we can have people like Jasmine, because we are a non-profit and have very little in the way of funds. Flying her over to us would be quite challenging. So it's great to be able to talk to you here.
Hmm.
It is a very casual, relaxed atmosphere. Do just ask questions. And this time we are going to be having a conversation generally about life on other planets, atmospheric science, and rogue planets. So, first of all, because I'm sure it's nothing to do with Marvel and living planets or anything like that, what is a rogue planet?
Yeah, so a rogue planet is, it's kind of like the name suggests, it's a planet that's gone rogue. It's a planet that got kicked out of its solar system and it now freely floats through interstellar space without orbiting a star. So it's kind of sad, but you know, it happens.
And I imagine rogue planets, of course, they won't reflect light from a star. They won't
Mhm.
really have much in the way of infrared, I'm guessing. How do you detect and study them? What do you look for?
Yeah, so there's one technique that I know that we use, which is called gravitational lensing. So it's kind of like looking through a magnifying glass. So any object in space has mass, and that mass is going to kind of bend the light that's around that object. So think of like a galaxy or a star or something. It's going to bend the light that's around it, and so we can kind of use that, the way that the light bends, to kind of see, okay, there's an object there. Um, so that's how we detect rogue planets.
And once you've detected them, obviously that's probably the easiest bit of it. How do you learn more about them once you've just spotted them?
Yeah, it's really difficult because like we know that they exist, but it's like how do we study them? Since we study exoplanets by, using their stars, and the effect that their stars have on them to figure out their atmospheric composition and such. So it's like, how do we do that with a planet that's just kind of freely floating through space? I imagine when we have more advanced space telescopes such as James Webb and such, it'll be better for us since these telescopes are going to be way more powerful. So they can probably study these. It's so strange to think about the fact that we can detect so many of these planets that are way far away from our solar system, but we still don't know much about our own solar system. We have so many questions about, the outer ice giants like Uranus and Neptune. Like, oh, I always think about that.
Sorry, wrong button there. We had a question come in, and I think we might
Okay.
have another one. I'm just trying to clear that up. So
Okay.
gravitational lensing, you say it's like looking through a microscope or through a magnifying glass.
Yeah.
I'm assuming it's not exactly looking through
Yeah.
a magnifying glass, but the question was, is it the same gravitational lensing that's used to image black holes?
Yes, I believe so.
Okay. And there must be distortions. I mean, you've not got a perfect piece of glass. How do you deal with noise? Gravitational noise. Is there gravitational noise?
There probably is. I mean, I know, there's always going to be, that signal to noise ratio, and it's a good question. There's always going to be, these planets are so far away, so I don't even know how we're dealing with the noise in the first place, because these exoplanets are far away, and like we're getting these precise numbers when it comes to their masses and such, and I don't know. I'm assuming, astronomers are looking over and over again to make sure, like, did I see something? Like, is there something there, So I'm assuming, like, repeated over and over again, they're going to check to make sure it wasn't just a fluke.
And another one, I hadn't actually thought of this. So planets are very small for a
Mhm.
given value of very small. Normally, you would just look around a star to find a
Yeah.
planet because we know they orbit things. How on earth do you know where to look for rogue planets? Because I know that space is mostly made up of space.
Yeah. Um, that's actually something that I was thinking about yesterday, because I'm writing a post about voids in space, how there's just areas that are empty, or mostly empty. Um, so I'm thinking that like we must be like looking everywhere to find something, like, and they're probably like within our stellar neighborhood, like they're probably really close to us, we're probably not going super far out just because of our technology and our limitations. Um, but it's the same question, like, are we looking in the right place for life? Like, we're not finding anything right now, but are we looking in the right places for signs of alien life? Are we looking in the right places for these planets? I'm assuming we're just kind of pointing our telescopes and seeing, oh, there's something there. It's probably more complicated, but
So that's interesting, because if we're wildly or vaguely pointing telescopes and detecting rogue planets, it suggests there might be a large number of them out there just for us
oh
to
yeah,
spot
there
any.
are. I actually saw when I was doing research on this that there are more rogue planets than there are stars in the universe, and if you know that if you know the number of stars, which is like in the trillions, then that's scary.
So when you say rogue planets,
Mhm.
are we applying the same criteria that we do to the 8 planets in our solar system? I think it's 8 now, unless we count
Yeah,
Planet X. I know we don't count Pluto anymore, or do we again?
don't.
As the joke goes, it's not as if demoting a planet named after the god of death was a bad idea, but
Odd.
yeah. So do we apply the same criteria to rogue planets, that they must be of a certain size, that they can't be orbiting a satellite, or there can't be a satellite?
Probably. I don't even know. I think some rogue planets have satellites. Not that I know of. I don't know how many we've actually discovered. But they probably do. I know, like, with exoplanets, like, we've discovered them in all sizes. But when it comes to habitability, we're looking for Earth-sized planets that are in the habitable zone of their star so that they could support liquid water on their surface. So I'm assuming that, rogue planets, it's kind of the same thing. Okay, you want a certain size, because then if it's too big, it's going to be like this. If it's too small, it's going to be like this. But we don't even know about the climate on rogue planets. So how can we have that conversation when we don't even know about what climate, what their climates are like, what their atmospheres are like, if they even have atmospheres?
Yeah. And we've got a question from Narula, or a few
Sure.
questions. So first one, I hadn't even thought of this. I'd been thinking about, okay, you just point a telescope that sees gravity. Obviously, it doesn't actually work that way. I'm assuming there isn't a telescope that translates gravity waves or gravitons or whatever they are into visual. So the question is, firstly, do you have direct access to the equipment to search for such planets in space? So have you accessed the gravity telescopes, or before that, what are they? How do you, what equipment is used to detect the to do gravitational lensing, or to detect rogue planets through gravitational lensing?
That's a good question. I'm assuming it's like similar to the equipment that's used to detect exoplanets.
Okay.
I'm just trying to imagine what these telescopes look like, and I'm assuming it's like the really big telescopes that we use. Not like Hubble or anything, not like the ones that are just taking pictures of galaxies, but like, yeah, I'm just imagining really big telescopes.
And well, the next couple of questions was, is there a specific name or brand of the equipment? I would assume they're probably custom built.
Yeah, I would assume that NASA is just not giving that information out to the public.
Yeah, so they're generally bespoke. And how, you've mentioned very big telescopes. How big are we talking?
That's a good question. Well, let's think about Hubble. How big is Hubble? Hubble's detecting galaxies that are far away, so like, think about how big the telescopes are that we're just using to see our own solar system, and then multiply that, because we're seeing planets that are light years away. So I could imagine pretty big. I can imagine not for the average consumer. They're probably located in their own observatories.
I was just wondering about that. I mean, obviously with radio telescopes, we have huge issues with
Yeah.
just noise generally. The whole areas where you're not allowed to have any electromagnetic signals, and your house must be tempest shielded to prevent radiation from affecting the
Yeah.
local observatory. With a telescope that's looking at gravity, is it something where there's going to be a space-based option so you can get away from the fact that on Earth we've already got plenty of gravity?
Mm-hmm. So you're saying like putting it in space?
So we're talking more about gravitational detectors,
Yeah.
I'm assuming. So are there any space-based gravity detectors? Are there going to be?
I'm not sure if there's any currently, but there honestly should be, just because, like you said, there could be a lot of noise, and also like we could detect so much more if we're sending it further out from Earth. We could, find stuff that's even further away, because there's a lot of limitations by being here on Earth. So I hope that we send stuff out in the future. I always like to think about future space missions. What are we sending just in our solar system? We're sending stuff out to Titan soon. We're sending stuff out to other moons. I hope we send stuff out to Uranus and Neptune soon, because that's the one that I'm really excited about. But yeah, I hope we get some in the future.
Okay, so on that excitement, what was it that got you so excited about astronomy? Because I've seen you mention you were excited about it when you were a child, you're excited about it now. It's not really diminished. If anything, it's got bigger.
Yeah.
So what is it that fascinates you so much about it?
Well, for me as a kid, it was just, looking up at the stars and the moon and just being amazed. Your mind wanders when you're a kid. You're very curious. So I would always think about, oh, humans on the moon, just these wild ideas that kids have. In the car, I would look at the moon and I would imagine, oh, it's following us home, because, you can see the moon the entire drive home. And then when we get home, I'd look out at the moon again. I was like, wow. And then in 6th grade, I took an earth science class, and one of our units was about space. So we learned about each of the planets. And I just got really excited because like, wow, they're so cool, compared to Earth. Like, they're so different, the range just in our solar system of these planets is amazing. And so from there, I knew like, oh my God, I want to do this, for the rest of my life. And the path has not shifted. If anything, it's gotten, even better, because I've pinpointed exactly what I want to study, right? So ever since then, I've just been buying astronomy books and talking to people, and, my major is planetary science. So it's exactly what I wanted to do. So I'm just getting closer and closer. I think it's just the mystery of it all. We don't know that much about space. I mean, I know that they say, okay, we know more about space than we do about our own oceans, which is scary to me. But we still don't know that much about space, There's so much out there. The observable universe is only what we can see. There are things that we don't even know exist because the light hasn't even traveled to us yet. So that's insane.
Do we actually know if we can see most of the observable universe or not?
I feel like we can, because the age of the universe, relative to, Earth. So I feel like we can.
Sorry,
but there's still.
I misspoke. I meant to say, do we think that the universe is mostly made up now of the observable universe?
Oh, okay. Well, that's interesting to think about, because we know that the universe is expanding, every single minute. So I'm not sure, because it's like, maybe it's like getting even bigger and bigger, and we just don't, objects are getting further and further apart. So maybe at this point we can only see, a little drop in the bucket. We don't even know at this point. And it's so weird to think about, you know, how far apart things are and how big things are. And oh my God. That's something that would make my mind wander to think about.
And we've got a question from Sarah back
Yeah.
to rogue planets, so coming
Oh
down
yeah.
in scale again, and in fact coming down a lot more. Could we have rogue planets in our solar system that we haven't found yet? And I'd
Oh
just like to
wow.
add something to this one.
Yeah.
Are there potentially rogue planets in our solar system which are no longer rogue?
Oh my God. That's something to think about. Well, the way rogue planets, since I haven't mentioned it, the way rogue planets become rogue is in the early formation of these solar systems. You can have interactions between planets that are forming, right? So you'll have a gas giant. So, you know, you'll have a really big planet with a very strong gravitational pull, and you'll have another planet that kind of gets caught in this pull and kind of gets flung out of the solar system. You know, it becomes like a slingshot, right? Because we use, like, it's, you know, this is not a new thing. We use the poles of other planets to kind of fling probes out further into the solar system. So that's how planets become rogue. You know, they get flung out and they can't come back into the orbit of the star. That would be interesting to see if we had a planet like that in our solar system. I don't think we do. I remember learning about the formation of our solar system in one of my classes I took last year. And I don't remember him mentioning anything about this, but it'd be interesting to look into. I don't know how we would find out if that happened. But I would imagine we don't have any, just because, you know, if we're seeing rogue planets that are so far away, I would imagine we would have already found one by now in our own stellar neighborhood. So I would say I'm not sure right now. I would say no for the most part, but that would be interesting to see, you know.
We've got a mention from Chris. I may have been wrong about the gravitational detectors, or I may be on
Oh, okay.
completely the wrong track. So his mention is with gravitational lensing, he thinks you see a particular sort of pattern indicating an invisible object. So I guess closest thing on Earth would be something like heat waves. You can tell something's there because there's
Yes.
distortion, but there's nothing coming off it. And the
Yes.
pattern would be much bigger than the planet, because obviously you've got the whole gravitational field, which is
Yes.
theoretically infinite, but I don't do infinities. Could that be a field for amateur astronomers, or something like folding at home, where you're searching the sky or searching data for that sort of regular pattern where there's something that indicates a gravitational field, but you cannot detect an object at the center of it?
I think that would be interesting to get amateur astronomers into that, because, you know, they could really help out the field. I'm not sure how powerful your telescope would have to be to detect such a thing. So I would assume you would need a more expensive telescope to do that. But I think that would be really cool, you know, to have this field. And I definitely think it's a growing field, especially with the field of exoplanet detection, since we're detecting, you know, I know we use different techniques for exoplanets like transit and, you know, direct imaging and stuff like that. But I definitely think this could be something that we could do here. I just think it depends on the telescope and how powerful it is.
Okay, and I know we've glossed over or not really mentioned atmosphere so far.
Oh yeah.
But I remember years ago, more years than I'd care to mention, reading a short science fiction story where a wandering black hole had come through our solar system and yanked the Earth out of orbit and cast it into space. And we've got a question related to this. So could we live on a rogue planet, either if one was, say, passing through and we could travel to it, let's assume we've got the technology to travel there, or if for some reason Earth became a rogue planet without killing everyone on it? Is it possible for, firstly, us to live on something like that, and secondly, for anything to live there?
Yeah, so rogue planets, you can imagine, if there's no star, you know, when we think of life, when we think of what's important for life. Our star is very important to us because we need that energy to grow food. We need it for photosynthesis. You know, we get vitamin D from the sun. It's very important for us. And also it regulates the climate of our planet, right? We're at the perfect distance to have such a climate for humans to exist. But when you don't have a star, you can imagine the planet is very cold. However, there are also ways that the planet can maintain heat. From the formation of the planet, the early formation, there's lots of heat. And actually, there have been studies done that suggest that actually the planets can hold on to heat from their early formation in their cores. As long as the core of the planet does not get iced over, or, you know, something like that happens to it, then it can actually hold some heat. And it would be able to keep its liquid water. If it had liquid water before it became a rogue planet, it could actually hold that liquid water under a thin layer of ice. Now, would we be able to live on it as humans? I'm not sure. I just think the climate wouldn't be good enough for us. It would be very cold. So, you know, then again, we're trying to go to Mars, and Mars is pretty cold. So maybe. But with microbial life, that's another question. Microbial life could actually be able to survive under that thin layer of ice as long as the planet has some sort of heating mechanism within its core, or, you know, some other outside source. So I think microbial life could live on them. I'm not sure if we could, just because of the climate and, you know, how cold it would be. I even saw that if the planet was like a lava world, since lava worlds do exist, you know, covered with volcanoes and stuff, the volcanoes would actually be, you know, they would spew out, you know, whatever they're spewing out, and then it would fall back down as snow. So, you know, then the world would be covered in snow. So just imagine, you know, living on a world covered in ice and snow. You know, it wouldn't be favorable for humans, but I think microbial life, you know, we have extremophiles on Earth that live in such extreme conditions, like, you know, in the bottom of the ocean, you know, vents in the bottom of the ocean, but also in like volcanoes and stuff. So I definitely think microbes could live on such a planet.
Okay, so we couldn't really live on the surface, even if there were
No,
volcanoes.
yeah.
I mean, I'll be honest, I wouldn't really want to live on a lava world. In any case, it sounds bad, but right. So potentially there could be heat, there could be some sort of energy residual, or I'm not sure you can really call an active planetary core residual energy, although it's technically right. It just seems like a lot of energy to call and heat to call residual. But if microbial life could live, so you've obviously got something in the oceans where there is something hospitable to life. Could there be anything more complex theoretically, or would you be likely to just have that microbial?
I feel like life, this is also part of the study that I was reading about that was conducted. I think you could have life that evolves from, or more complex life that evolves from the microbes in the liquid water that's trapped under this layer. I don't know how complex it would get. You know, I don't think it would get to the point like we did. You know, we definitely got lucky. But I definitely think it would be more complex than just what starts off in the oceans, you know, the little microbes, because that's how all life started off on Earth. You know, we had these little like unicellular bacteria, and then it just started growing into multicellular organisms, and then eventually we came from that. But I definitely think it could evolve. I don't think it could be complex. You know, there was a video I watched where it was talking about, you know, how common is life in the universe, right? And it said that life, based on the probability, there's very complex math that was involved, based on the size of the universe and everything, how many planets there are, how many stars there are, life would be common, but intelligent life would be rare. And I definitely stand by that point. I believe in aliens, but they're not the aliens that we see in pop culture. They are just, even microbial life, that counts as aliens. It's not originating from Earth, so it's still an alien. So yeah, life would be common, but intelligent life is rare.
Sorry, some headphone trouble there. Is that the Drake equation, working out how
Yes,
much life there
I
is?
find it very interesting. I really love the Fermi paradox and the Drake equation. I like looking into it just to see, like, you know, how did we even come up with, you know, how did he even come up with such an equation? And, you know, how are we, you know, we're plugging in hypothetical variables for each of these, you know, we're plugging in hypothetical numbers because we don't know. We don't know the number of planets that could support life. You know, each variable becomes unknown, except for, like, there's like a couple we know, but like after that each of those is unknown. So our answer is just hypothetical at this point, and we don't even know how long our answer is going to be hypothetical for, because, you know, we haven't discovered everything. We can't really discover everything.
Okay, I'm curious about the Drake equation and digging a bit into it. So
Yeah.
for those who don't know, it's a relatively simple equation. It's just a load of multiplication of probabilities. And it's about how much life there would be in the universe, depending on, I've just got it up here, I've not memorized it, I'm cheating.
Yeah.
Number of civilizations we could communicate with is equal to the average rate of star formation, the fraction of stars that have planets, the number, basically work out the number of planets that could support life, work out, then multiply that by the probability of life developing, then multiply that by the probability of intelligent life, and then multiply that by the length of time that intelligent life can communicate for before it goes extinct, develops beyond anyone who might receive the message, whatever happens. So up to a certain point, we know that because we know the average rate of star formation.
Yes.
We know we've got an idea of the number of stars that have planets. We're probably not perfect on it, but you know, within a range, we know it's not zero. And then maybe we can work out the number of planets that could support life, etc., etc.
Yeah.
So fundamentally, let's start with this one. Can we say, or do astronomers say authoritatively, that none of those variables can be zero because we exist?
I think I read it in the book Cosmos by Carl Sagan. I think, I don't think any of the variables can be zero, because then, you know, it wouldn't work out. Like, how would we come into the equation? So I definitely think that that's true, because then the whole thing becomes zero, because anything multiplied by zero is zero. So then the whole thing is zero. So then it doesn't make any sense. So yeah, I think they have to be, you know, at least like 0.00001, you know, whatever, but they have to be greater than zero.
And is this part of why there's so much excitement about finding life even in our solar system?
Yes.
Because it gives you an idea of one more of those variables, which helps you to build out and work it out from there.
Yes. And the reason I believe in life outside of Earth is because how did we get here? You know, I know everybody asks that question, but, you know, Earth can't be the only one. It just doesn't make sense, you know. And we found so many planets that are, you know, very close, you know, they're in the habitable zone. They could support liquid water. They have really good temperatures, but then there's always one thing that throws them off, you know, whether it's the climate or the atmospheric composition or something that throws them off. But we're getting closer and closer. And I definitely think Earth can't be the only one. You know, we talk about our own solar system, and we have rovers on Mars, and they're seeing like ancient riverbeds that are dried up, and, you know, that indicates that there had to be water on Mars. And I did some research on Venus, and Venus used to be like Earth as well in the early formation of the solar system, when the sun was much smaller and fainter. Venus used to be in the habitable zone instead of Earth. And it's just so interesting to think about in our own solar system. Maybe our closest neighbors used to have life, and we won't know because, you know, they've become the way that they are. So if our own solar system has that, then there has to be something out there that is similar.
Okay, so let's go with Venus, because I'm curious about this now. What sort of period of time was it in the habitable zone for?
Yeah, it was around 700 million years ago. So do the math on how old our solar system is and all that. So yeah, it was when the sun was still young, and it was still growing to where it is today, because the sun is still aging. The sun's going to be, it's going to turn into a red giant one day. We know that story. So yeah, this was when the sun was still really young, and Venus was, it was at the same location that it's at today, but its climate was much different because the energy from the sun was much less than it is today. We know that Venus is basically hell. It's really hot, and there's a runaway greenhouse effect with the atmosphere and how much carbon dioxide is in it. But it couldn't have always been like that. It couldn't have always been super hot because the sun wasn't always super hot. So yeah, Venus, it is thought that Venus used to be like Earth as well when the sun was younger. And then when the sun got bigger and bigger, the oceans evaporated, and the water vapor went in the atmosphere and absorbed all that sunlight and heated the planet to what it is today.
Okay. On this idea of, every exoplanet we find seems like it's a potential and then has something off. Is it possible that somewhere out there, different galaxy, whatever, there is some sort of intelligent life looking at planets and saying, everything seems almost ideal, except it's got too much oxygen, it's got water, it's too cold,
Oh, so you're
stuff is
thinking,
liquid, it's
yeah.
too hot, there's an atmosphere, that type of thing. Is that, I mean, there's this whole thing of alien life might be completely alien and work on
Yeah.
not different physical laws or chemical law or biochemical laws, I guess, but ones that cannot work in our environments. Is that something where we can know whether or not it's a possibility?
So you're talking about life evolving in completely different conditions than Earth?
Yeah.
Oh,
Where
wow.
the fundamental essentials of
Yeah.
life are utterly different from
Oh,
our own.
okay. Okay. Yeah, I think that could be possible. I mean, think about, Mars and Venus. They couldn't have entirely been like Earth. They have, they have completely different atmospheric compositions now, but I'm assuming their early atmospheres were much different. But they couldn't have been exactly like Earth. I'm thinking like there has to be something that evolves in different conditions. There has to be life that's not even, I think there have been a ton of studies about life that's not carbon based, because we're carbon based life, and what that would be like. And I think that would be totally interesting. And maybe we are looking in the wrong places. Maybe the Fermi paradox is true. Maybe we're just, in the vastness of the universe, we're not looking in the right places for life. And maybe another maybe another alien civilization isn't looking in the right places, and we just won't make contact. It's scary to think about, but
Slightly to one side, I don't suppose you know any biologists who specialize in extremophiles, because I kind of want to set up a panel now at some point.
There has to be. I think there are some that are following me. I could always check and try to set you up.
Yeah, I'd love to do that as a special panel with you talking about it
Yeah.
from the astronomy point of view,
Yeah.
them talking about it from the biology.
Yeah.
Everyone loves the idea of alien life, so
Oh, yeah.
that would be a fascinating one to do, and
Yeah.
we'll look into it after this. We have had a few questions. Sorry, I got distracted quizzing you about aliens.
Yeah.
Is it actually hard for a planet to stay in orbit around its star, or are rogue planets something that tend to only form in the early stages?
Yeah, from what I've seen, yeah, rogue planets only form in the early stages, just because, when they're formed, they have their set elliptical orbits and they're just kind of doing that forever. So yeah, I think they form in their early stages, but since they're so common, I mean, they have to be, it has to be happening like all the time. When a solar system is forming, something just gets knocked out. Now, when it comes to the size of these planets, rogue planets are mostly very small, because they have to be able to be the right size to get caught in the gravitational field of a gas giant. So they can't be too big, or how are they going to become a rogue planet? So yeah, rogue planets are mostly pretty small, and they get flung out and stay that way, which is very sad, but it happens.
Actually, on that, I know I can't remember how many generations of stars we've had or theoretically had, but it's a number. Stars last for a very, very long time
Yes.
from our point of view. And since there have been multiple generations, is it actually possible that in intergalactic space between the galaxies, there are larger rogue planets drifting from earlier generations?
Yeah, there probably could be. I mean, I don't know if we have an exact estimate on the sizes of rogue planets, but I would imagine that, they could be slightly bigger than we're thinking. I mean, there could be Earth-sized ones, such and such, but I don't know how big they could be. I don't think they will be the size of Jupiter or Saturn, something really big. That wouldn't make any sense. But I definitely think they could be bigger than, they could definitely be bigger than Earth. I don't know how big, but yeah, it just wouldn't make sense if they were the size of Jupiter. That I would wonder how that happened.
I suppose even if they once were, they wouldn't be anymore.
Oh yeah, that wouldn't make any sense to me at least.
So fairly easy for a planet to stay in orbit once it's formed.
Yeah,
Basically.
it would just, I mean, our own solar system, it's been like this for, how long? So yeah, they just kind of do their own thing. And unless something, we talk about, this is definitely not related, but Uranus is knocked on its side. And it's theorized that, in the early formation, stuff was just knocking into it, and eventually something really big knocked into it and just tilted it on its side. So maybe there are things that could theoretically knock the planets out, but I don't know how big that would be, just because it would have to be super big, because our planets are very big in their own right. So it would have to be something really big coming in and knocking our planets, but I doubt that would happen.
Okay, how would you set it up, or if you were designing your own solar system or
Yeah.
building your own solar system, let's say you can do that, how would you set it up that you've got something big enough to turn the spin of a planet 90 degrees but not knock it entirely out of its orbit?
I know, that's so crazy. It's so funny to think about, that it only hit one of our planets and it knocked it 90 degrees on its side, and it still has all the characteristics of a planet and everything, and there's no sun, and it has rings too. Uranus does have very thin rings that people don't really talk about, but they are there, and I think they might be from whatever knocked it. I don't know, but they could be. Yeah, something really big sorry, I have my own, I'm looking to the side, but I have my own little solar system floating in my room, so hanging from the ceiling. So I'm looking at them and just wondering what could knock it. And it's we think about asteroids and comets, flying by Earth and not hit, just barely hitting us or something, but we never think about how big something could be to entirely knock our planet on its side. And I don't even know. But also we think about how fast objects are traveling in space. They are traveling very fast. And so, even a small, even an impact from something very small could, have devastating impacts. We've seen that with Earth. We've been hit by things, and there are giant craters that are seen, and the impactor was very small. So it could be that something of a decent size was traveling very, very fast, and just the impact was just monumental, and just it had enough force to kind of turn the planet. So I do think, it does depend on the size, but even size, it could be any size and still have an enormous impact because of the speed that it's traveling at.
So it might have enough energy to spin it, but not to.
Yeah.
But then how does it stop? Why does it
I
stop at
know.
90 degrees?
I know that. Yeah, I remember last semester in one of my classes, we did an experiment, and it was based on Uranus. If Earth was tilted that way, how would its climate be? And Earth's climate would be completely different if we were knocked 90 degrees. So thankfully we have our own little tilt, but it's not enough to, completely change what we know. So we got lucky that time.
Okay, so a few more questions.
Yeah.
This one goes back a bit to the one I was asking about our fundamental assumptions about life. Might we be misled thinking that life needs a star?
Ooh. Yeah, we probably are because, we evolved and we have a star. So we're probably thinking, you have to have a star because it provides such crucial energy for this planet. It regulates the temperature and everything. So I'm assuming, yeah, like we probably have been misled. We've, like you brought up earlier, we're probably misled thinking that we need oxygen, we need an atmosphere, we need liquid water. Maybe other planets out there that have life don't have those things, and they're completely different than what we think of as a habitable planet. I mean, that would suck because that means astronomers are looking in all the wrong places, but
Well,
that's another topic.
so just on that one,
Yeah.
because there's one thing that I can potentially see that's different between life needing a star and not. That if you've got a star, you've got energy being input to the system over time.
Yes.
And yes, all right, billions of years later, the star explodes and eats your planet. Let's not get
Yeah.
into that.
Yeah.
But you've got a longer lifespan because there is that energy coming in, or
Yes.
you've got a longer viable lifespan. If there was life, even complex life, evolving on a rogue planet, would it always be exothermic? It would always be losing energy. Ultimately, it would be doomed to,
Oh, yes.
frankly,
Yes.
freezing.
Yes.
And obviously, over timescales of evolution, as well as astronomical timescales, it might be that even if complex life evolved, it's not going to last long enough to
Yes.
matter.
Yes, that is correct because, it's always going to be losing energy. There's, it's holding on to whatever heat is in the core, but that's not going to last forever. I did see that in the study that I was reading about, a planet that's about, I think, 3 Earth, it was a fairly small planet compared to Earth. And it could actually be able to hold on to a liquid ocean for 5 billion years without freezing. But that too, it has to be smaller than Earth because, it has that energy and, relative size. A bigger planet is going to lose heat faster. So I think only the smaller planets compared to Earth are going to be able to hold on quicker or longer compared to bigger planets. So, but yes, it is possible that it can hold on for a fairly long time before eventually freezing over, and then there's no hope left for any life.
Okay, so a couple of related ones then.
Yeah.
Mixture of the two, and going back to that question, could Earth eventually, or any time really, be, because things move fast over long, I don't know how fast it would be, we'd probably
Yeah.
have some warning, but could Earth potentially be flung out of our solar system to become a rogue planet? And related to that,
Yeah.
if it did, what would happen? Given that the core is still molten, we've got an atmosphere and we've got some level of intelligence. I mean, how long could you live off that heat? How long could you preserve it if you're deliberately preserving that energy? Let's
Yeah.
ignore the fact we're not particularly good at long-term thinking as a
We're
species and
not.
assume we
Yeah.
get there because a black hole's just ripped us away from the sun.
Yeah. I don't think Earth could be a rogue planet. It's interesting to think about, but back to my original point, in the early formation of the we have to have some kind of interaction gravitational wise to fling us out, and we are very far away from Jupiter and Saturn and, bigger planets that could theoretically do that. Now, could we have an outside interaction that could do that? I don't know. We do have a black hole in our own galaxy. And that's something else to think about. But I don't know if, that black hole is not big enough for us to be affected by it. So I don't know if Earth could become a rogue planet. But hypothetically, if it was, how would we survive as a species? That is something to think about. I mean, things would be changing very rapidly for us because the oceans are not going to be looking like they are now. And the atmosphere, we might be able to hold on to it. That's something else that's in, studying right now. People are studying, could rogue planets hold on to atmospheres? That is something that I'm not sure about. I don't know what would happen to the moon. I don't know if we would keep the moon or if the moon would just kind of drift away from us. I mean, it is drifting away, but Would it stay with us? I'm not sure. But definitely things would change very quickly. The climate would be colder, much colder. But I'm sure scientists would be definitely looking for ways to preserve that heat. What would we do to keep ourselves warm, scientifically speaking, what would we do? And engineering would be definitely, we would need some good engineering to keep us warm. But maybe we would move to another planet. People are talking about moving to other planets and, what life would be like there. A lot of people want to stay on Earth, though. I agree. I kind of want to stay on Earth just because that's what we're used to. And I also don't want to disturb any other planets, Even if there's nothing on there, I just kind of want them to be the way that they are. We've already messed with Earth enough, We've already used up a lot of resources and we're affecting it in negative ways. So, yeah. I hope that we can just keep our own planet.
Okay. I think we'll do one more question and then
Okay.
relax. So this is from George and Barbara.
Sure.
If intelligent life evolved on a rogue planet, and we are going into science fiction almost again here, or not almost, but if intelligent life evolved on a rogue planet and it was able to master fusion, would it be able to survive beyond the freezing of that planet? And I'm assuming part of that is also, would it be able to prevent the freezing of that planet? At that point, it almost sounds like you're talking a planet-sized spaceship or a planet-sized vessel with bubbles of spaceship on it. But
I definitely think it could be possible. I mean, we always talk about, hypothetically, there could be civilizations that are more advanced than us. Like, we call ourselves very advanced, but think about when technology was just getting started. That actually wasn't that long ago, Obviously, we've been advancing at a very exponential rate, but there could be civilizations that are way advanced from us. There could be civilizations that are already traveling out or using other planets and, et cetera, things that we think as science fiction, but if there was an intelligent civilization on a rogue planet, they could definitely be way advanced than us to the point where they've already converted that planet to, like you said, a vessel that they're kind of just using whatever they have to preserve their life and prevent that planet from freezing, and killing them off. So yeah, I definitely think, in the realm of science fiction, your mind will wander so much, but is it entirely fiction? We don't know.
I'm going to sort of wrap up here for at least the people watching on YouTube and so on, and then we'll have a quick chat after we've gone off live. But I don't know if you've heard of the Dunning-Kruger effect.
Yes, I have.
Yeah. You mentioned, obviously, there could be civilizations more advanced than us, who've worked out how to preserve their life on a rogue planet.
Yeah.
This isn't really a question, it is a summing up, but the Dunning-Kruger effect, for those who don't know, is the idea that as expertise grows, your confidence initially drops, and it drops quite dramatically. So the less you know, the more confident you are at the beginning. So when you know nothing about a subject, well, it must be very easy because you lack the skills to critically evaluate your own ability. When you start learning about it, what you realize is you don't know much about it at all, because suddenly you've got the skills to do that and you can go, I didn't know that. Now I want to know that, but I didn't know that. And so there's this massive hit to confidence early on, and it takes a very long time to build up to the point where your confidence is at the same level as that complete amateur in the subject. Do you think, when we're talking about advanced species, rather than applying on an individual level, it would be entirely possible that we're talking about Dunning-Kruger on a species-wide level? So something that's been around for 5 billion years longer than we have is way off the end of that curve, where we're at this point of thinking, oh, we've got it all nailed, we understand it now, and we're just about to hit a slope.
Yeah, I definitely think that because, even in the field of astronomy, there is so much that we don't know. That is the whole point of this field. That's why people go into it. We're trying to answer these questions, whether it comes to life, whether it comes to how we got here, stuff like that. I definitely think we are probably on the low end of that scale. Like we probably think we know, but we could just discover something one day that completely changes what we thought we knew. um and it's scary to think about, oh, maybe we are just wrong, but that's the whole point of learning. We want to learn, are we wrong? Like what are we doing wrong, what are we doing right, so that we can kind of plan for the future and plan future observations of planets and stars and stuff. So yeah, I definitely think we're on the low end of that, or maybe in the middle. We know we don't know some things, but we're still kind of confident.
Thank you.
Yeah.
So if we wrap up the sort of public section there, thank you for coming on. It's been absolutely brilliant. If we can just stick around in here for a bit, I'll explain what we normally do next, and then you can, I was going to say go to sleep, but of course it's not the same time there.
Yeah.
But to everyone watching at home, which is everyone, but to everyone watching not from the room, have a good night. I hope you enjoyed it, and obviously do follow Jasmine online. We've tweeted enough about her, and just the passion about astronomy is
Yeah.
amazing to see. So thank you for coming on.
Thank
And
you.
I am going to, if I can just find it. That's what happens when you close windows without looking at them. There we go. So I'm going to take us offline.